So in this class we are going to see about the ionic process. Okay, the why we need for the ionic method. Okay, you see the water. So all I know about the H2O molecule. Okay, so the water is used for the domestic purposes and industrial purposes. Okay, that is well known. But thing is, we are collecting a different source of water. So river water and pond water and borehole water, even sea water. Okay, so we should know about the impurities. So what kind of impurities are present in the water? Anyone? What kind of impurities? Huh? Plastics. Okay. So we classify three types of impurities. So one is the chemical impurities, physical impurities, and biological impurities. So there are three kinds of impurities. First one is the physical impurities. Second is the chemical impurities. And third is the biological impurities. Okay, so there are three kinds of impurities. Okay, you take any kind of water except rainwater, so it contains the impurities. So we mainly classify three categories. Okay, there's a physical and chemical and biological. He said also the one kind of impurity is the plastics. So we observe the river side and sea side. So these are the frequently we observe. So these are the physical impurities. We can easily remove the filtration method. Whereas it is not applicable for the chemical impurities. How can we remove it? So you know that. So 1 gram of salt dissolved in the water. How can we filter it? How can filter it? For example, you have the 1 liter of water. You add the few grams of sodium chloride. How can you remove it? Filtration method is applicable? Applicable or not? It is not applicable. And biological. So biological impurities means in terms of unwanted bacteria. So what kind of bacteria are available? So many bacteria are available in the water. So that's why the municipality, the announcements, you go for the boiled water in the rainy season. Why they said frequently this kind of statement? So the removal of the biological impurities. Okay, the above 100 degrees Celsius, it removal of the all kind of bacteria. So these are the well-known impurities for the everywhere in the water, except rainwater. So remaining all water body contains these kind of impurities. So in this method, the ionic method, especially the removal of the chemical impurities. So in the chemical impurities, it means you see here the plastics, wood, and leaves and plants, plant waste. Everything is so that is the macromolecules. Everything is a macromolecule. We can easily remove it. Whereas the chemical impurities, we don't know. So the size is very tiny. So less than nanometers. So that we can't do for the any filtration method. This is a simple filtration method. So the chemical impurities, like what kind of chemical impurities are possible in the water bodies? I already told, as I told you, sodium chloride is one of the impurities. NaCl is the one kind of impurities. I don't want for the NaCl. If you go for the food preparation, you add it the sodium chloride. Otherwise, drinking water not necessary for the NaCl. So it is considered the impurities, chemical impurities. And additionally for the calcium chloride, and magnesium chloride, calcium carbonate, magnesium carbonate, calcium sulfate, magnesium sulfate. So these all are salts form. the particular salts, and many salts are present in the single drop of. Okay, but we go for the industries, for the production industry, textile in the nearby, there's a Coimbatore nearby cities production of textiles. The main textile industries is based on the water sources. Tirupur is one of the textile industry. Here also in Coimbatore also top of the industry is there. Okay, so pouring industries, textile industries used for the plenty of water per day. Nearly 5 lakh liters or 10 lakh liters per day. For the treatment process, what kind of treatment? The manufacture of textiles, so washing and dyeing, so different steps are there. So we need for the purest form of water, no need for the impure form of water. Okay, so we remove all of these kind of impurities by this method. This is ionic process. Okay, so the ionic exchange method, the removal of the chemical impurities like salts, like calcium chloride, magnesium chloride, then sulfur, calcium and magnesium sulfate like that. So in this method we have used the 2 columns. So one column with the cation resin and another column filled with the anion resins. Okay. So you know that, so where, for example, we take for this example, this one, this is a salt. How can write this cation and anion? Yes, exactly. This is a Ca2 plus SO₄, 2 minus. This is a cation. This is a cation. This is a anion. Okay. So in this method, ion exchange means they exchange the ions. So it is a removal of calcium, another resins, removal of the sulfate ions. So that we use it for the 2 columns. So cation resin and anion resins. The cation resin is removal of calcium and anion resin removal of the sulfate. Okay, so that this kind of approaches, the impure water is converted into the pure water. This is a simple approach. Okay, the removal of the chemical impurities by this method. So we inlet water is the impure form of water, but we should remove of the which one? Physical impurities. Before going to pass through the ionic process method, we remove for the physical impurities first stage, and second stage only the chemical, and third only the biological. Okay, even virus also pretty tiny particle. Virus. So bacteria is a micron size. So micron size or nano size, any kind of bacteria or virus. So only the process. You go for the temperature above 100, 1 degree Celsius. It will roll up the all kind of bacteria. Okay. You also observe that, no? So whenever use it for the boiled up water, the bacteria is moving or stagnant in the water, normal water. Stagnant. No, it is moving. You just drop of water in the microscope, no? You see that is a moving. Only the microscope. Naked eye we can't see about the movement of the bacteria. So we don't go for that kind of investigation. That we boil the water. What happened? It's completely destroyed the bacteria. Okay. Where it is after the boiling, where it is available, the kind of bacteria? Huh? Where? It's at top of the water. So that is looks like some that's layer. So that is, it confirms that all bacteria are killed. It's floating on the surface. Okay, but we can't remove the salts. So only this kind of method we can remove this kind of salts. Okay, this is one of the simple and inexpensive method we can convert the impure to purified water. Okay. So any doubts? No doubts. But why we are doing such kind of approaches means we maintain the quality of water. So this ionic changer method is not suitable for the drinkable grade, only for the industrial applications, for the textile industry or cement industries and so the pharmaceutical industries. So that kind of industrial approaches, this is the best one. Whereas we go for it for the domestic level water, we go for the reverse osmosis, RO system. Okay. So any doubts? So next one. The distilled water also almost that is a man-made material. We remove for the all salts. So there is a condensation method, no? Just boil the water and it comes to vapor. The vapor is condensed. So we correct the purified water. Okay, no need for that kind of water. That's also purified water. Rainwater is a naturally available purified water. Okay, distilled water is man-made. So that also not. So this is one of the simplest method. This is one of the simplest method. But distillation method means we go for the boiling the water. So that is a method only for better for the laboratory purposes. Okay, this is only for the large scale production. Purification large scale only for the textile industry and the production business is possible. Okay. Any other doubts?
Any other methods to remove biological purification rather than boiling?
Yes, UV, no. UV treated water. So there's you see here the RO system, no? The RO system, it has here reverse osmosis as well as the UV treated. Okay, and chlorinations also. So today also we have seen the chlorination experiment, no? So that method also, chlorination means to kill the bacteria. In the municipality water add the chlorination. Okay, so we have different approaches. The chlorine is already available in the water. Okay, purposely we add the chlorine to kill the bacteria. Okay, any other doubts? Okay, thank you.